Okay, good afternoon, finite math students. Let's do another video. Let me just take a drink of water really quick. Just give me a moment. Okay, so in today's video, I'm going to tackle, let's say, 4, maybe 5 of the homework problems in Chapter 2, the Chapter 2 assignment. So let's take a look at that. Okay, so excuse me, the first problem we're going to do is number 61. The graph of the function g is formed by applying the indicated sequence of transformations to the given function f. Find an equation for the function g and graph g using the following specifications. So we're going to form a graph. The x values will lie between -5 and +5, and the y values will also be between -5 and +5. So that's a square. That's a square. It's 10 units long in the x direction, and it's 10 units long in the y direction. I hope that everyone can understand that. If the x range is from -5 to +5, and if the y range is from -5 to +5, well, what is 5 minus a -5? That's 10. So we have a square that's 10 by 10. And it says here, excuse me, the graph of f of x is equal to x squared is reflected in the x-axis and shifted 2 units to the right and down 3 units. Okay, so the first thing we're going to do is start Mathematica. Let's do that right away, okay? Excuse me, I have just a little bit of a sore throat today. Okay, one more time, let's get some water. Okay. Click on New Document. And I'm going to try to resize this just a little bit. Format, edit style sheet, input, output. Okay, so I want to change my input and output so that this will be easier for all of us to read. Format, show fonts. Let's make it 18. Personally, I like Arial. We can make that midnight blue, which is a nice dark, deep blue. I happen to like that. Let's do the same thing with the output. Make it bold. Font size is 18. Excuse me. Make it a nice dark blue, which I think is a little prettier than pure black. Your choice. You know, you choose whatever color you want. We already changed the color, right? Midnight blue. My dog is barking in the background. Let's try to ignore that. And let's choose Arial. And the background color, let's say, how about a light green? Very pretty, nice to look at. Okay, just ignore the dog. There's really nothing I can do to get him to shut up, so we'll try to ignore that. This is one of the challenges of working from home, so we're just going to make the best of it. Okay, so let's get back to the problem. Okay, let me try to resize this a little. Well, there we go. Okay, so the function is f of x is equal to x squared, and we're going to transform that into g of x. Now, it says here that the function is reflected in the x-axis. If something is reflected in the x-axis, then what that means is instead of f of x is equal to x squared, then I have f of x is equal to negative x squared. However, that's really not going to change things very much. Why is that? Well, x squared is actually equal to negative x squared. And that's true because if you have a number like, let's say, 3 times 3, that's going to be equal to negative 3 times negative 3. Okay, 9 is equal to 9. 3 times 3 is 9, and negative 3 times negative 3 is also 9. Okay, and then if you have, 10 squared, is that really equal to negative 10 squared? And the answer is yes, because they're both equal to 100. 10 squared is 100, and negative 10 squared is also 100. So if you reflect this, well, actually, you know what? In this case, okay, hold on one second. I have to think about this just a moment. I have the function x squared. X goes from, let's say, negative 5 to 5. Hold on one second. You know what? I stand corrected. I stand corrected because if I reflect this parabola, this is a parabola, by the way. If I reflect this around the x-axis, you know what this is going to look like? It's going to look like this. Basically, I just turned it upside down. So this is actually going to be negative x squared. And then it's shifted 2 units to the right and down 3 units. So if I shift this over 2 units to the right, I know you're thinking you should add 2, but actually you're going to minus 2. It's counterintuitive. It's like, wait a minute, but if you're shifting this over 2 units to the right, okay, you're actually going to subtract 2. Okay, so now my function looks like that. So the original function, this was the original function. Oh, sorry, x squared. Let me, put another list brace right over here. Okay, so this was the original, the blue, the line, the curve in blue is the original function. This looks kind of orange to me. The curve in orange is the transformed function. So we shifted it over 2 units to the right. And we also reflected it in the x-axis. And now we have to shift it down 3 units. And that's going to be pretty easy to do. That's just negative 3. And, or actually, yeah, you could do it that way. You could do negative 3 minus, or you could do minus 3. Actually, it doesn't, it's really not going to make a difference. It's your choice. I personally think this looks a little nicer, negative 3. So, okay, so the function in blue, the blue curve is the original curve. The function, the graph in orange, this is the transformed curve. So let's see if this is true. Let's see if Pearson agrees with me. So we have negative 3 minus x minus 2 to the power of 2. Check answer. Okay, so that is correct. Okay, and now I have to choose which graph is the correct graph. Which graph is the correct graph? So let's see if we can reproduce this in Mathematica. Okay, so just to reiterate, let me make this very clear because I hope you guys are listening and really understand. The original function, this is f of x. This is the original function that I'm highlighting with my cursor. f of x is equal to x squared. G of x is the transformed function. G of x is the transformed function. So first, I put the negative in front of x squared, and this flips the function over to the other side of the x-axis. I subtract 2 from my variable, and this shifts the entire curve over 2 places to the right. And then to shift it down 3 places, I have to add -3 or -3. That's the transformation. Okay, if this does not make sense to you, please read about this in your textbook. You have an ebook. You do have an ebook. You need to read about this in your ebook because I really want you to understand this concept. All right, this is it's not. I wouldn't say it's not the most important concept in the course, perhaps, but nonetheless, it is an important concept. And if you don't understand this concept, then you don't understand college mathematics very well, okay? So you need to get it. You really need to get it. Okay, let's make this picture. Let's see if we can make this picture, okay? I'm going to use, oh, here, hold on one second. Why did I just do that? Let me just put this back. Okay, there we go. Okay, so let's make sure the cursor is on the next line. We're going to use the plot command again. -3 minus x minus 2 squared. X will be graphed over the range -5 to +5. My plot range, now look at this, guys. The plot range is given right over here. X is between -5 and 5. Y is between -5 and 5. So therefore, X range is from -5 to 5, which is basically just a repeat of what I'm doing over here. And then the Y range goes from -5 to +5. Okay? So there I'm specifying a specific range. In this picture right here, Mathematica automatically, determines the range for me. It's going like from what, -50 to +30. That's really not what I want though. For the picture, I want the Y range, the vertical range, to go from -50 to like +30. Okay, and let's say the plot style could be red, and it could be thick. Oh, they have a blue line. Sorry. Well, that we could do blue. That's fine. We could do blue, maybe dark blue. So red, green, blue color, no red, no green, and a touch of blue. And we could make the line kind of thick. And I guess that's good enough. And let's say ticks. Okay, and that's going to be, well, for, you know what, their window, you know what, they made a mistake here because they're talking about x goes from -5 to +5. They're actually using a window of -10 to 10. So they actually, their directions are really not, they made a mistake. Their directions are not that terrific. Let me change, because if you look at the pictures, yeah, that's really interesting that they did that. Hold on one second. So they're not being, the rules here are not very consistent. Their directions are not very consistent. Okay, so this is going to be, I'll pick a letter K. K goes from -10 to 10. And the same for the Y range, -10 to 10. And let's see what we have for right now. Shift Enter. Okay, well, it's not a bad picture, but it's not terrific. I would, the axes are not equally, what's the word I'm looking for? The axes are not equally, the axes are not equal in length. The axes are not equal in length. So to change that, I would use the aspect ratio command and make it 1, which simply means that the y-axis and the x-axis have the same length. So that actually looks significantly better. We could also do this. We could do grid lines, automatic, automatic. Okay, why am I not getting my grid lines? That's weird. Let me do this. I'll make it the same as my ticks. K goes from -10 to +10. And the same, whoops. Let me close that. And -10 to +10. And let me just make sure we're okay here. There we go. Okay, now if, by the way, if you're wondering what does the table command do? I'm sure some of you were wondering, what the hell does table do? You're confused, right? It's very simple. Pick a letter, your favorite letter. Okay, my favorite letter is A because I plan to get an A in this crazy course, right? So A goes from -10 to +10. What does that do? Okay, so all it does is it generates a list of values that range from -10 to +10, and the default step is always going to be 1. I can change the default step. I could do this. Let's say the default step is 5. Okay, so now my increment between successive values is 5. -10, -5, 0, 5, 10. And if I don't supply a step value or an increment, the default of 1 is chosen. So -10, -9, -8, -7, -6. You get the idea, all the way up to 10. Okay? I hope that makes sense. I hope that makes sense to you. All right? That's what table does. It generates a sequence. It generates a list of values that fit a certain pattern. Okay? So I hope we're clear about that. Let's get back to the picture. Okay, so this picture doesn't look too bad. It looks good enough. Okay, the picture I mean, we could do more with the picture. We could add a title, we could label the axes. There's a lot of stuff we could do, but I would say, for right now, I mean, this looks pretty good. Let's say the background is white. Okay, I mean, it's good enough for now. So, let's see, which picture does this resemble? Well, certainly not A. Definitely not A. B is a candidate. Forget about C, forget about D. So you know what? The answer is B. The graph of g of x has to be choice B. Okay, because that's what we're getting over here, right? That's what we're getting over here. It makes perfect sense to me. I hope it makes perfect sense to you. Let's check the answer. Okay, so that's correct. Okay, no big deal. Excuse me. So, guys, I understand there's a lot of homework. This is very hard material. I get it. But because this is an asynchronous online course, you really have to take the initiative to do a lot of studying on your own. I can help you out. I can help you out the best I can, but because this is an asynchronous online course, and we do not meet regularly, not even for video lectures, you really have to do a lot of independent study. So this is not the best way to learn for everybody, right? I understand that. Hopefully, I hope things get back to normal in a few months, maybe next year. I really don't know. This COVID-19 thing stinks, right? It's turned the world upside down, but it is what it is, and we just have to try to adapt, right? Okay, so let's try to do a couple more questions in your homework. Okay, so so number 62 requires that you graph a piecewise function. And let's do this in Mathematica. We're going to graph a piecewise function. Now, I kind of forgot the syntax of piecewise, but that's not a problem. I can look it up. I can, wait a minute. Let me just clean this off. I have some dirt on my computer. Okay, there we go. Let's look this up. Oops, my cursor is back here. Well, okay, I don't, hold on one second. Let me just erase that. Okay, piecewise. Now let's see. I'm gonna press local. So this is a description of Mathematica's piecewise function, which is what we should use for number 62. You don't have to, but I recommend it. Okay, the conditions are typically inequalities such as, okay, so we have a list here. Let me see here. But Okay. If all the preceding conditions yield false, then the value I corresponding to the first condition that yields true is returned as the value of the piecewise function. Piecewise conditions automatically evaluates to piecewise conditions 0. Okay, so I think I remember how to do this. So guys, if you know there's a command in Mathematica that can help you, but you forgot the details, simply type 2 question marks, the name of the command, and shift enter, and you will get a brief description of the command. You can read about it, and you can see some examples, and that way you can figure out on your own how to use the command. If none of the conditions apply, okay, let's see, piecewise uses default value val. If none of the conditions apply, the default for value is 0. Okay, so I think I remember how to do this. Okay, so this is what we're going to do. Okay. F of x is equal to piecewise 3 minus 2 times x if x is less than 2. Okay. X plus 1 if x is greater than or equal to 2. Okay. And let's look at this picture. What does this picture look like? What does the picture of f of x look like? Plot f of x on the interval x goes from -6 to 6. Why am I choosing -6 to 6? Take a look at these graphs. X goes from -6 to 6. X goes from -6 to 6, right? So that's why I'm choosing those values for the x-axis, okay? The plot range, well, x goes from -6 to 6, which is what we have already, and then y goes from -10 to +10, correct? And my grid lines table, k goes from -6 to +6, those are the X tick marks, and Y. Okay, table goes from let's see, -10 to +10, and grid lines. Okay, we'll just do the same thing that we did. Oh, what am I doing here? Hold on one second. Oh, I'm just repeating myself. And ticks, we'll just do the same thing that we did for the grid lines. -6 to 6. And -10 to +10. And let's see, what colors should I use? Plot style. How about thick? And we could use dark blue again. So red, green, blue color, no red, no green, and a touch of blue. Okay. Now again, if we want to resize this a little bit, okay, so we should use the aspect ratio command. Aspect ratio, as you can see here, the x-axis looks much longer than the y-axis. So let's think about this. The y-axis goes from -10 to +10. That's a distance of 20. The x-axis goes from -6 to +6. That's a distance of 12. Okay, 5/3, but let's make this a decimal. Okay, let's keep it as a fraction. Okay, so ideally, then, I really want the y-axis to be 5/3 as long as the x-axis. So aspect ratio will be 5/3. That's stretched out a little bit too much. Well, oh, all right, let's just use 1. That looks great, okay? So which picture is it going to be? Is it going to be, well, it's definitely not going to be A. Choice A doesn't work. Choice B doesn't work. It's either going to be C or it's going to be D. But which one? C and D look very close, but they're not exactly the same. So it's going to have to be D. And the reason that it's D is this. Look very carefully at the definitions of f of x. If x is less than 2, not equal to 2, but less than 2, then the definition of the function is 3 minus 2 times x. If x is greater than or equal to 2, if x is greater than 2 or x can be equal to 2, then the definition of the function is x plus 1, which means that the point 2, x is equal to 2, corresponds to this definition right over here, not this definition. So the point, 2, x is equal to 2, belongs to this half of the piecewise function. Therefore, what we want is choice D, which is, the correct answer. I mean, you could also put that in your graph, although that's going to take a little bit more work. You could put it in the graph, but I would rather not show that to you right now because that is going to take a little bit more work to do. So for right now, just don't worry about it, okay? Okay, we are running out of time. This video is getting a little too long. What I would like to do, I would like to look at, let's say, one problem in your Chapter 3 homework. One problem in your Chapter 3 homework. So let's take a look. Hold on one second. Chapter 3 is the finance chapter, which I'm sure you're all going to enjoy because most of you or all of you are business majors. So let's take a look at your finance homework. Let's do one of the more challenging problems. Okay, let's do, 1 second, let me resize this a little bit. Okay, let's do one of the more challenging problems. The easier problems at the beginning of the chapter, I really don't think you guys need my help on those, but there are some problems in the Chapter 3 homework that are definitely challenging. Okay, so let's take a look at one of those, just one, because I think this video is starting to get a little bit longer than I would like it to be. Okay, let me take a look at problem 52. No, that's not what I had in mind. Okay, well, this one, 70 is okay. We could do 70 and maybe one more after that. So it says here, let me turn on my magnifier. What will a $100,000 house cost 4 years from now if the price appreciation for homes over that period averages 6% compounded annually? Okay, well, that's actually not a very hard problem, but let's take a look at that. Okay, so my price appreciation rate is 1.06. Shift Enter. Okay, so that means I have $100,000. $100,000 is the cost of the house. $100,000 is the cost of the house. And I'm going to multiply that by the rate 4 times. Rate times rate times rate times rate times the cost of the house. And that's going to give me, and I would like to round that out to 2 decimal places. Thank you very much. Number form, infinity, 2 decimal places to the right of the decimal point. So that is going to be $126,247.70. $126,247.70. Let's see if we're okay with that. Okay, let's just do one more problem and then we're going to call it quits. I really don't want these videos to get too long. Okay, because I realize, after a half hour, most students just lose their concentration and really just, even if the video is playing on your computer, you just kind of stop watching and listening and you start, shopping on eBay or Amazon or something like that, right? Okay, let's do this. This problem actually was not that difficult. Let's do one that's a little bit more challenging. Excuse me. Okay, problem 90 is a little bit harder, although that's not, super hard, but let's work on problem 90 in your chapter 3 finance homework, okay? Oh, yeah, this problem is actually kind of challenging. Okay, let's take a look at it. Find I, the rate per period, or the interest, and N, the number of periods for the following annuity. Monthly deposits of $225 are made for 3 years into an annuity that pays 8.5% compounded monthly. Oh, actually, that's actually not that difficult at all. This is, okay, this problem isn't that hard. So if it's 8.5% compounded monthly, here, let me put my cursor right here. on my Mathematica window. So 8.5%, change that into a decimal, and then divide by 12, because there are 12 months in a year. Okay. Or we could get the same answer by just doing this, 8.12 divided by 1200. And then it says here we need to type an integer or decimal, round it to 4 decimal places as needed. So we could round 8.5 divided by 1200, round to 4 decimal places as needed. So the interest rate is 0.0071. That's the interest, per period. That's correct. Excuse me. And 3 years. So what is n? Again, that's actually, this problem isn't that big a deal. So n is simply going to be, well, we have 12 months times 3 years. That's 36. So n is equal to 36. Okay, so that's really not a big deal. Let's try to do a problem that is a big deal. I thought some of these problems were a little bit more difficult. Hold on just 1 second. Okay, so I like number 128. This will be our last problem for this video. This one's definitely more challenging. This one is definitely a more challenging problem. So let's take a look at this. If you buy a computer directly from the manufacturer for $3,263 and agree to repay it in 36 equal installments at 1.71% interest per month, on the unpaid balance, how much are your monthly payments? How much total interest will be paid? Okay, so it's 1.71% interest per month. So the rate is going to be 1.71, but we have to divide by 100 to change the percentage into a decimal, okay? And I'm going to do this using what's called a recursive function. Recursive function, and I'm going to say balance, a balance of time, or I could say balance month. I'll call my variable month, and you really need that underscore, guys. The underscore here is not an option. Okay, you have to use the underscore. I mean, you can name the variable whatever you want to call it. X, Y, Z, time, month. I don't care what you call it, but the underscore is definitely not an option. Please remember that, okay? The underscore is not an option. The name is up to you, the name of the variable, but the underscore is not an option. Colon equals rate, let me see, hold on 1 second, times balance month minus 1, which simply means what I owe this month is equal to the rate times the balance that I owed the previous month minus the payment, okay? And then balance of 0 is equal to 3, should probably use my colon equals. Balance of 0 is going to be equal to $3,263. Shift, enter. And it says here, okay, I have to repay this whole thing in 36 months. Balance of 36 months. Oh, okay, so I should expand this. Sorry about that. Let me expand it so that it's a little easier to look at. Hold on just 1 second. I think we're okay here. Hold on just one second. I think we're doing this correctly. Let me just take a look at my results because this number is almost 0. This number is actually almost 0. So did I make an error? I think we're okay. I think we're okay. So then I need to do this. Balance 36 is equal to 0 because after 30, excuse me, after 36 months, I owe nothing. 0 here represents I owe nothing. 0 means I'm done paying for the computer. I owe nothing on the computer because I'm done paying for it. What is my payment? Shift Enter. You know what? There is something. Oh, I know exactly what I did wrong. Okay, okay. What I did wrong was I forgot. Okay, the rate, guys, I made a mistake with the rate. It's 1 plus. 1 plus 1.71% divided by 100. That's the mistake. I knew something didn't look quite right. So let's do that again. Rate. Let me clear balance and do this again. Put my cursor here and Shift Enter. Shift Enter. Yeah, that looks way more reasonable. Shift Enter. Okay, that looks way more reasonable. So my payment is going to be, yeah, remember guys, it's 1 plus my interest rate. 1 plus the interest rate. Sorry, I think I almost made a big mistake. So $122.13. Does Pearson agree with me? Pearson agrees with me. The total interest paid is going to be, well, this one's easy, okay? This one's easy. So $122.13 a month, and times 36 months minus, what do I pay? You know, what was my, how much money did I initially borrow? How much money did I initially borrow? It was this much. So minus 3263. There's my answer, or I could simply do this: $122.13 times a month times 36 months minus balance 0, right? It gives me the same answer. The total interest is going to be $1,133.68. That's the total interest spent on the loan. That's the total interest spent on the loan. And that is correct. Yeah, so I almost made a big mistake. The mistake was, remember with the rate, it's 1 plus the interest rate, because otherwise you're going to end up with something that doesn't quite make sense, okay? It's not going to quite make sense. Okay, I think we did enough for today. I will try to make at least one more video this week. I hope these videos are helpful to you. Don't forget that you also have tutorial videos in Pearson. Let me see if I can find some of those for you. Let me see. You have to do some fishing around in Pearson, guys. Okay, no, that's not quite it. Syllabus in PDF format, you really should take a look at this, guys. This is my syllabus. Okay. The e-text. This is your e-text. View the e-text for your course. Okay, this is your e-book or the e-text, and you can, read it. I strongly recommend that you read it. Some students, they lie about this. They'll say, oh yes, Mr. Lewitt, I swear to God, I'm reading the book. And I know that they're lying. They're not reading the book at all. I strongly recommend you actually do some reading because the book may explain things better than I will. The book may dispel some of your confusion about various topics. So I strongly recommend you spend some time actually reading the book. All right. There are also tutorial videos here. Multimedia library. Multimedia library. I believe that the multimedia library contains tutorial videos on all kinds of topics in the course. Although for some reason, it's not loading right now, which is a little weird. It could be because of my Wi-Fi signal. My Wi-Fi signal is okay, but it could be a little bit better. Well, anyway, if you go into the multimedia library, guys, you should find access. Oh, here we go. Finally, okay. Um, Animations, learning activities, PowerPoints, activities, interactive figures, the multimedia textbook, the videos. The videos are fantastic. I really recommend that you look at some of the tutorial videos. I'm not talking about my tutorial videos. I'm talking about Pearson's tutorial videos because I think they're going to help you a lot. So you have all kinds of options. There's no reason for anyone to get a D or an F in this course if you just spend some time, working on this course. So, for example, Mathematics of Finance, Chapter 3, show me the videos. Oh, wow, we have a lot of videos here. Wow, this is amazing. Okay, Mathematics of Finance, 6 minutes and 29 seconds. The simple interest rate earned on an investment. These guys. These are great videos. You need to watch these videos, plain and simple. Um, if you don't like to read that much, if you're not a big reader, then by all means sit down and spend an entire afternoon or an entire evening simply watching these tutorial videos because I believe they will help you tremendously. Although still, I suggest you read the textbook. And I also suggest that you look at my tutorial videos because if you don't, it could be kind of difficult for you to figure out how to use Mathematica. And remember, we will have a couple of assignments in the class that are completely 100% based on Mathematica. So I do expect everyone in the class to understand the basics of Mathematica. I don't consider that optional, okay? All right, so I think I've talked more than enough. This video is probably way longer than I want it to be. And that's it for now. And I hope you guys have learned something really useful from this video. And if you're confused more than ever before, please read your textbook. Please look at Pearson's tutorial videos. And please email me with your questions. I'm very busy, but I will do my best to answer your emails as soon as I possibly can. Okay? Thanks. Have a great day. And it would be helpful if I could turn this off. Okay, here we go.